Hi, this is Sean Gould with the first of two ITnet 198 screencast presentations, and for this first project I have elected to complete the LAN Switching Lab. And what I'm going to do in this presentation is first just give you a brief overview of the topology that's seen here, and then go into some of the key configurations on each of the devices that we see in the network, and then finally give just a brief demonstration to show that connectivity has been established through this network and that end devices are able to communicate appropriately. So let's begin by taking a look at the topology here, and we can see that we have a number of end user devices, simply desktop PCs, that are connecting to a switched network that is composed of three individual switches, which are then also connected in turn to a router, which will allow for inter-VLAN routing, which we will discuss in a few moments. And as you look at the topology here, we see first of all our end user devices are connected into the network via Ethernet connections, and then that the switches are connected to each other by trunk lines, which are simply allowing for the communication of data back and forth between the switches, as opposed to our direct Ethernet connections to the PCs, which are allowing for the user traffic to be initiated onto the network. Now, down below we can see a representation where our end users have been split up into different groups which are being assigned to separate virtual networks or VLANs. So in this case we have one group of users that are considered the faculty staff, so we have a network presumably being used in an educational setting, and some of our users are faculty and staff members. Those users are grouped together into one virtual network. We have a separate virtual network of students that have been set up in their own VLAN, and then we have a third VLAN set up for guests that might be accessing the network. And there's different reasons why we might want to do this. First of all, by dividing our user base up into separate VLANs, we are, for each separation, we are reducing the size of a broadcast domain. There's also some security benefits to be had by separating out. For instance, it may not be appropriate for the student population to be able to access some of the same applications and data that the faculty and staff members are able to access, and so by separating them into their own virtual networks, we're able to maintain that separation of access. And you'll also notice that we have a fourth VLAN mentioned up here on our network diagram, VLAN 99, and that is the management VLAN where the network administrator would be able to access the system, the network, and make whatever configuration changes that he might need to make or conduct any maintenance to the network, but that access would be restricted from the other VLANs. Now, because each of these VLANs operates as its own entirely autonomous network, in order for those VLANs to have any sort of connectivity to each other, it is necessary on the network to have a router to perform inter-VLAN routing. And so we see that on this topology, and we'll go into that configuration in a few minutes. First, though, let's take a look at how these VLAN assignments are made in the switching hardware. And so I'm going to pull up the interface for our switch that the end devices are connected to, and they are password protected, so we'll get in here and access the privileged mode, and we're going to give it the show VLAN command and be able to look at a couple of things here. First of all, by looking at the VLAN configuration on the switch, we see here where we have VLAN 10 for faculty and staff, corresponding to our faculty and staff VLAN as shown on the topology. VLAN 20 for the students, VLAN 30 for the guests, and if you look off to the side, we notice that each one of those VLANs has specific fast Ethernet ports on the switch that have been assigned to those particular VLANs. So for instance, in this case, any computer that would be connected to this switch on Ethernet ports 0, 11, 12, 13, 14, 15, 16, or 17 would be considered part of the VLAN 10 for faculty and staff. Likewise, Ethernet ports 18 through 24 has been assigned to the student VLAN 20, and Fast Ethernet ports 06 through 010 have been assigned to the guest VLAN. And again, keep in mind that even though all of these devices and ports are present on the same physical switch, logically they are distinct networks when we're talking VLAN 10, VLAN 20, VLAN 30, and so devices on any one of those VLAN assignments would be unable to communicate with a device on another VLAN without the assistance of a router to perform inter-VLAN routing. Another thing also to keep in mind, however, is that even though we have gone ahead and assigned some additional ports to each one of those VLANs beyond what is shown on the topology map, not all of those additional ports within each VLAN have been activated. And so I'm going to show you next, we're going to get into the running configuration on this switch, so you can see that. And first of all, if you'll notice, our first several Ethernet ports, and it's going to be port 01 through 05, have been set up in trunk mode. And so again, those are the ports that are just simply going to be handling the communication flow of data from one switch to the next. And so we see again here we have port 02, 03, 4, and 5 all set up in trunking mode. When we get down then to Ethernet port 06, this is where you can see on our running configuration, let me just tab down a little bit more here, a couple things I want to point out. First of all, we see here that this particular port has been set up and assigned to VLAN 30. And you'll notice also I threw in a little something extra that was not depicted in the lab, but it is an interesting and potentially important security feature that I wanted to highlight, and that is the ability to activate port security on a switch. And so I have activated that on here, and in this case what I have activated is a switch port security that will remember the MAC address of the individual devices that are connected to a switch port. So the switch essentially learns which device is intended to be connected to a specific port, and it will only allow that specific device access to the network through that port. So if someone were to unplug a computer from or a specific device from the switch port, plug in a different device, the switch would recognize that the MAC address had changed, and at that point would shut that port down and deny access to the network through that port. Now this particular port is through the guest VLAN. That security or that level of security may not be as important for that particular VLAN, and it could be deactivated and left in place on the other VLANs only. But again, I did want to highlight the ability to have that security feature. So again, and going back to the point I was originally making, from our show VLAN command earlier, we saw that multiple ports had been assigned to each VLAN, but if we look here, Ethernet port 07 has been assigned to VLAN 30, but it has not, that port has not been activated. It is administratively down. So if an additional device were to be connected to this network, an administrator would have to go in and activate that port in order for communication to be able to take place. Continuing on down the configuration, here we start in at port 011 with our VLAN 10 access, and again that those security features that I mentioned, you can see it has already learned the MAC address of the particular device that is connected to it, and again if that device were to be changed, if someone were to unplug it and plug in a different computer, it would not work. And again, some additional Ethernet ports administratively down. Here we have the beginnings of our VLAN 20 access, assigned again by individual port. and we come to the end of our running configuration on switch 2. So now that we have talked about individual port assignments and VLAN assignments, let's take a look at VTP, which can be very important administratively when dealing with VLANs. And I'm going to go up here to switch 1 and again log on. And the idea with VTP is that when we have VLANs on this switch network, administratively it can become quite a chore if you had multiple switches that you needed to go and individually configure every time there was a change to a VLAN, if you needed to add a VLAN, subtract a VLAN, and so forth. And so we can use VTP, VLAN Trunk Protocol, to automate a lot of that. And so each switch in the network can be configured as either a server or a client in VTP. And in the case here of switch 1, this switch has been configured as a VTP server. And so what that allows us to do is we can go in and make any any VLAN changes to this one switch, and because it is set up as a server for VTP and our other switches I'll show you are set up as clients, and you can see that right here. So any changes that we make back on that VTP server will be propagated through the network automatically, so that the administrator does not have to go through and manually configure each individual switch. So for example, if we were to, here on our server, VTP server, if we were to go into configuration mode and add a new VLAN 40 that we did not previously have, we can then go back over to our other switch. Oops. Helps if you give it the right command. And you can see that now VLAN 40 has been propagated down to the client switch using VTP. And so again, that can be a very useful administrative tool in order to keep up with VLAN management without having to individually configure every switch. And we can go back up here and take that unneeded VLAN back out, and again returning to the switch. The client switch will now see that VLAN 40 is gone again. So again, just a demonstration quickly that VTP can be a great administrative tool. Okay, so that leaves us with one last major component of our switch configuration to talk about before we go to the router itself, and that is STP, or Spanning Tree Protocol. And by way of brief background, the way switches forward information over the network is that they will, in the event of a broadcast on the network, they will forward traffic through all of their ports other than the port that the traffic came into the switch from. And so when you have multiple switches hooked together, as we do in this particular topology, it would be possible for a broadcast to end up propagating around the network in a loop and creating a broadcast storm, which would ultimately eat up all the bandwidth in the network and bring it down. And so in order to prevent that, we can implement STP, which has been done in this configuration. So I'll show you up here. A couple of places where we can see STP, and the first one, we'll just look quickly at the first few lines of the running config. And if you notice right here, there's a line in the running configuration indicating that we have Spanning Tree operating in rapid PVST mode, and we'll talk about rapid STP here in a minute, but that is the first place where we can see that Spanning Tree is in fact active. And then we can also do a show Spanning Tree command. Hi, this is Sean Gould, and this is part 2 of my screencast on the LAN Switching Lab for the ITnet 198 class. And we were just looking at the use of STP on this particular network, and we had looked at the running configuration on one of our switches and noticed that we had STP running in a rapid PVST mode. And we also wanted to look and see some additional information about spanning tree by using the show spanning tree command. And we can see here that on each switch we have 4 ports that are acting as trunks to forward communications amongst the switches, and each one of those switches using the STP protocol is able to choose amongst those trunk ports and decide which ones should be placed into a forwarding state and which should be placed into a blocking state in order to prevent broadcast storms from propagating around the network. And that protocol is in place on all 3 of our switches. Although each switch will have its own determinations as to which particular ports are open and which ports are blocked. And the switches then will also be able, using STP, to make adjustments as things change on the network. If there were to be an outage on a particular segment of the network, or if there were to be a topology change that affects these trunk lines, STP would be able to react and unblock ports that had been blocked and place them into a forwarding state in order to maintain an open line of communication around the network. And that brings up a discussion I mentioned earlier, that we're running an STP mode called Rapid PVST, and basically Rapid PVST is a mode of spanning tree that allows for a more rapid convergence of the STP protocol when there is a topology change. In other words, if there were to be an outage and STP determined that it needed to begin changing ports from blocking states to forwarding states, it takes time for it to do that. And you can place switches into a rapid STP. It's a more modern version of the protocol, rapid STP mode, and then that will allow the switches to make those determinations and place the blocked ports into a forwarding state more quickly, so that your network is only affected for a minimum amount of time. And that wraps up our major components of our switch configurations, but we do still need to take a look at how our router is handling inter-VLAN routing for our various end users who are grouped off into separate logical networks. And so we're going to take a look at our router configuration. And first of all, I want to take a look here at our running configuration. And first of all, keep in mind, normally with a router you would need a separate physical interface for every individual network being connected to that. However, we are able to go in and create sub-interfaces using only one actual interface on the router. So for instance here, if we look back to our topology, our router is being connected to the switch network via its fast Ethernet 01 port. And when we look into the show running configuration, we can see that that has been configured into various sub-interfaces. So we have fast Ethernet port 0/1.10, and that would correspond to our VLAN 10. And we have a sub-interface fast Ethernet 0/1.20 for our VLAN 20, 1.30 for our VLAN 30. And you can also see that each one of those, let's scroll back up here, that each one of those sub-interfaces, you can also verify which VLAN it's associated with by looking at the IP address that has been assigned to it. So again, with our sub-interface 0/1.10, we said was affiliated with VLAN 10, and if you look at the IP address, we have a 172.17.10, and that corresponds with the VLAN 10 IP address that we've noted on the topology down here. So that's just one extra visual cue by looking at the running configuration that you can see which sub-interface is affiliated with which VLAN. But beyond that, the routing functions from there work much like they would in any other routing scenario. The sub-interfaces are in essence acting as their own physical interfaces and allowing the VLANs to communicate with each other. And we can also take a look at the routing table for this router and see that it is currently showing that it has 4 different networks that are directly connected to it, and each one of those networks are coinciding with our VLANs. So we have again our 172.17.10 network for VLAN 10, we've got the .20 network for VLAN 20, the .30 network for VLAN 30, and then we had our management VLAN over here. And so what we're able to do, now that we have seen that the router is configured into sub-interfaces, and each sub-interface affiliated or associated with a particular VLAN, we can go down and open up a command interface on PC number 1 here, which in our topology belongs to VLAN 10, and we can use it to ping over to PC 2, which is connected to the network on VLAN 20. And if our router is conducting inter-VLAN routing correctly, we should get replies from our ping, and we are doing so. So we can see that communication is taking place. We can check that again on VLAN 30, the guest VLAN. And there we go, we're getting our replies. We can go over now to PC2 and just confirm that it also is able to ping across to VLAN 30. And we can see that it is able to do so. So there we go. We have a functioning switched network using VLANs, VTP, STP, and inter-VLAN routing. Thank you for watching.